Hello everyone. Today let us discuss about vernier calipers and how to do experiments with vernier calipers. Yes, children. Let us see. Here, this is the vernier calipers. Okay, vernier calipers has mainly one main scale. This is the main scale. This is just like our ordinary scale. However, ordinary scale has divisions like centimeters and millimeters. The same type of scale we have. Okay, you can see the one which you have in your hands. Okay, then after that, extra what it is here is vernier scale. This is the vernier scale. If our vernier scale is perfect, then when you close this vernier calipers completely, these two are closed, that time 0 of the vernier scale should coincide with the 0 of the main scale when there is no error. Okay, if it doesn't coincide, that means there is a error. So this vernier calipers, what is the main use? It can measure very small diameters, very small things which we cannot do with the ordinary scale. Now here we have what are the parts of this. All the parts we will see in brief. This is the main scale, this is the vernier scale. And here this is the screw for our hands to move it front and back. And this screw is to tight it. Okay, you can make it loose. Once you close it, it becomes tight. So you can release this screw, then it moves freely. And this one, lower ones, these are called as lower jaws. They are movable jaws. Okay. So now after that, here we have upper jaws. What is the use of this lower jaws? Mainly to measure diameter of an object like this we can keep and we can measure the diameter. And upper jaws are mainly used to measure the inner diameter of a cylindrical object like this. Okay, so and other one, what it is here, this is the thin metallic strip. So this thin metallic strip is mainly used to measure the depth of a cylindrical body or something like that. So you keep like this, it should touch the bottom, and then you adjust this one. So until it touches the bottom. So now, yes. So like this we have taken. I hope you got it.
Yes.
Yes, children?
Yes.
Got
Yes.
it? Yeah. So like this we are taking. It should come and touch it. So we can measure the depth. So main thing what we have to know is, we have to know what is the main scale, what is the vernier scale, what is the least count. So here I am writing least count. Okay, so least count. So what is the least count? Least count is the minimum amount which you can measure. Okay, so you can see least count we have to calculate. How we will calculate? Now n vernier scale divisions is equal to n minus 1 main scale divisions. That means 1 vernier scale division is equal to n minus 1 divided by n main scale divisions. Okay, therefore 1 main scale division minus 1 vernier scale division, we call it as vernier constant. Now vernier constant is equal to 1 main scale division minus n minus 1 divided by n main scale divisions, that is equal to 1 by n main scale division. So this is called as this one, what vernier constant. So in this vernier calipers we have what we have, this main scale is in centimeters and millimeters. Now we want least count, minimum how much we can measure. So once you take this one, 10 divisions of vernier calipers is equal to 9 divisions of main scale division. Okay, so now once you substitute that, you will get the least count of vernier calipers is equal to 1/10 of a millimeter. 1/10 of a millimeter. That means 0.1 1 millimeter, that is equal to 0.01 centimeter. So the least count of this one is equal to 0.01 centimeters. Then what we have to do, you have to make one tabular column. So the tabular column I am doing rough, you have to do with scale and all neatly. Okay, simple. So serial number, first you take main scale division, next vernier scale division, let it be A, let it be B, then vernier scale division into least count, this is B into 0.01, then final reading A plus B, and A plus B is the final reading. So let us take, I will take one reading, the remaining you take. So here, this is the bob I took, pendulum bob I took. So just close it like this now. Okay, our vernier calipers has no error. Okay, so now exactly in the middle you take like this, and if it is not tight, you can fix this screw on the top. So Harshavardhan, can you tighten the screw? Yeah, so now if it is fixed like this, now you see what is the reading here. It's coming out. Yes, now it got fixed. So now you see, children, here if you see, what is the main scale division? You can see here, come. So now here, this is somewhere here 1, this is 1.5, this is 2. Okay, this division of the first division of the vernier, it is just after 1.9 of the main scale. Yes or no? Yes. So let us write serial number 1. Main scale is 1.9. Okay, main scale is 1.9. This is in centimeters. Then let us see which division of the vernier is coinciding with the vernier divisions. Can you see and tell me which one is coinciding? Out of these 10 divisions, which is coinciding?
7th.
Yes, look carefully and tell me. You should see without parallax, straight from the top. According to me, this one.
Yes, ma'am.
Am I right?
Yes, ma'am.
Yes. So that means that is the 1, 2, 3, 4, fifth one. Fifth one. So vernier scale division is 5. Then vernier scale division into least count, which is 0.05. So total reading, this is also in centimeters. So total reading is 1.9 plus 0.05, which is 1.95. Yes or no? Yes. Centimeters. So diameter of this bob is 1.9 centimeters. And similarly, I have taken only one reading. So now you take 2, 3, 4, 5, 6 readings minimum we take. Add all of them and divide by 6, you will get average value of the diameter. Okay. Now another thing I want to tell you, all verniers are not like this with 0 error. Some of the verniers will have errors in them. Scale will be like this. Like this, the main scale. And vernier scale, if you see the vernier scale, first division will come somewhere here. Main scale 0 is here, this is coming here. So that means there is a error. Okay? Yes or no, children? Yes, so there is a error. So whenever there is a error, you should see which division of the vernier is coinciding with the vernier, this one, vernier main scale. So now you select that one and then select that, then what will be the error? Whatever may be the number of division of the one which is coinciding with the main scale into least count 0.01. So that will be the error. So for example, if fourth division is coinciding, multiply with 0.01, 0.04 centimeter will be the error. Okay. So now when you are taking with such kind of one, you have to make zero error. That is zero correction you have to do. Okay, following, no? So you have to make zero correction, and then depending upon whether it is positive error and negative error, here you have to make adjustments with the zero correction. Okay, I hope you got it. Yes, no? So now you measure with this another one, that is inner diameter, same procedure, main scale division and coincided vernier scale division. And similarly, depth, already I have told you, like this you can do. Once you know this diameter and the depth, you can also find the volume of this cylindrical one. Okay, I hope you understood. Now we will see what are the errors, how we can rectify the errors. Now if you can see this figure, this particular figure, here 0 and 0 both are coinciding. So in this case there is no error. That means that 0 of vernier, 0 of main scale should coincide. Then this vernier is perfect. But in some cases they are not coinciding. In that case, what to do? Suppose if you take this particular figure. So in this particular figure, if you see, here is the main scale 0, here is the vernier scale 0. You can clearly see here, main scale 0 and here is the vernier scale 0. So then you have to see which division of the vernier is coinciding with the main scale. So here you can see 0, 1, 2, 3, 4th division is coinciding with the main scale. Therefore, in this case, what is the error? In this case, what is the error? This is 4th division into least count, that is 4 into 0.01, which is plus 0.04. Why it is plus? Because main scale is first and vernier scale is next. Therefore, it is positive error. So 0.04, this is called as the positive error. When you get positive error, from main reading you have to subtract 0.04. For positive error you have to subtract. I hope you got it. For positive error you have to subtract it. Yes or no, children?
Yes.
Yeah. Now, if you see this figure, 0 of vernier has come first and 0 of the main scale has come next. That means there is a negative error here. Here it is a negative error. So when there is negative error, once again you see what is the division which is coinciding, that is vernier division which is coinciding with the main scale. So here you come, here this is the 0, 1, 2, 3, 4, 5. 5th division of vernier is coinciding with the main scale. So here therefore the error is 5 into least count, which will be 5 into 0.01, which will be 0.05. But this is negative error. When it is negative error, we have to add to the main reading which we got. Got it? No?
Yeah.
I hope you got it. So in this the previous one where I have taken, there was no error, so I took the reading like this. Suppose if there is a positive error, you have to subtract here. If there is a negative error, you have to add here. So like that you take 6 readings and add all those readings, divided by 6, you will get the final reading. Okay, I took here only to save the time, only I took the diameter of the bob. Then but in the coming experiments you also have to do in the same way. Take this one, cylindrical shape, measure its inner diameter using the upper jaws as well as depth of the cylindrical object by measuring the depth by taking this strip down and measuring the depth. Okay, I hope you got it clearly.
Yes.
Now no more doubts. Yes or no?
Yes.
Shall we close?
Yes, ma'am.
Thank you for watching this video. We will meet in the next video with some other topic.